Let's begin. We're starting off quite easy. Most of this content you would have studied in your previous classes, especially IGCSE chemistry, if you've given that. So let's begin with point number one. It's talking about how in an atom you've got the most of the mass is concentrated in the center when you've got electrons orbiting far around it. Most of this space, it's quite empty. So yeah, moving on. Electrons and we're going to talk about the relative masses first. So a neutron and a proton, they have about the same mass. Their difference is quite negligible. So if we give them a mass of, apologies, if we give them a mass of 1, the electron, it's quite a lot smaller than these two. So its mass is one part when we divide the proton or neutron into 100 and 1836 parts. It's quite small in comparison. As for the charges, we all know a proton is positively charged. It's got a charge of +1. An electron is negatively charged. It's got a charge of -1. And a neutron, it hasn't got a charge. So you could just write a 0 over there. Moving on, we have to talk about these terms right here below. The atomic or the atomic number or the proton number, it's the number of protons. So if you can look down here at the periodic table we've got, so a hydrogen, it's got a proton number of 1. This is actually a bad example because the mass number is also 1. A hydrogen doesn't have a nucleus. Let's have a look at another. Let's have a look at gold. So gold, Au, it's got a proton number of 79 and it's got a nucleon number of 197. The difference of the two numbers is the neutron. So let me write it down here below. This should make it easier. This is gold. Gold has 79 and 190. It's actually 196.97. We can round this off to 197. This is the proton number and this is the nucleon number. Proton number, I'm just gonna write it in short form. Yeah. To find out the number of neutrons in gold, you're gonna have to subtract the two numbers, and this gives you what does this give you? So this gives you 118. We have 79 protons and 118 neutrons, and adding these two gives you this number over here. Moving on, we're on the fourth point, I think. Yeah, we've talked about the fourth one. Let's go to the fifth one. We have to describe the behavior of beams of protons, neutrons, and electrons moving at the same velocity in an electric field. I'm going to show you it's this one over here. I've drawn these beforehand, so they don't take a lot of time. A neutron, since it's got no charge in an electric field, this over here is an electric field with these two plates. This is a positively charged plate and this is a negatively charged plate. A neutron would move straight through these without any deflection, because it's got no charge and thus it wouldn't be affected by the electric field. An electron, since it's got a negative charge, it's going to be attracted towards the positive plate. Remember, opposites attract, and the similar fields would again, opposites attract and the similar sides would repel each other. So an electron would, this electron over here, it's going to hit the positive plate. It's not gonna move through the field, and it's not gonna move through the field like the neutron did. The proton, it's going to hit the negative field. There's one difference between the way an electron would act and a proton would act. Since this diagram is quite messy, we're gonna do it again down here. The electron is a lot lighter than the proton. So in an electric field, let's extend this out till here and here. The proton, it would hit the negatively charged plate after it travels some distance, because we're going to see the difference over here. It should make a lot more sense. The electron is going to hit the field after it doesn't travel much. Since it's got it's a lot lighter than the proton, it's not traveling with a lot of momentum, or to use the proper word, it's not got as much inertia as the proton. So I hope that makes sense. Just a little distinction between the way these two would act in an electric field. Moving on, we're on the 6th point now. I keep doing this. Alright, we're gonna have to talk about ions, and the 7th one, it's talking about the atomic radius and ionic radius. So let's get to point number 7 first. I'm not sure if I can annotate on here. Can I? Yeah, I can. So this is a periodic table. Down here, these are groups. These are all groups. And these over here, they are periods. So when you're moving from left to right on the periodic table, the radius of the atoms, it decreases, and when you're moving down from top to bottom down the groups, the radius of the atoms increases. The reasons are quite simple. So when you're moving down the group, the number of shells that an electron has, they increase. So the shells of electrons, this would be 1, this would be 2, and they increase as you go down the groups. So naturally the radius would increase. When you're moving through the group, through the periods though, so the number of protons increases, and when the number of protons increases, it pulls on the electrons in the outer shells with a lot greater force. Hence the electron, hence the atom, it shrinks just a little bit. So once again, when you're moving down the groups, the radius of an atom, it increases, and when you're moving along the periods from left to right, you'd find that the radius of an atom decreases. And a distinction between an ion and a atom is quite simple. So let's take hydrogen. It's the easiest example. uh, the blue circle, it's the proton, and here's the electron. This is the shell that the electron's traveling in. This is what a hydrogen atom looks like. An ion of an ion is basically a charged atom. And how's it charged, you ask? Well, when you look at atoms, they have an equal amount of protons and electrons. Hence, the charges, they are balanced out. But in an ion, there's usually uh, more or less electrons, either one of these two. So with a hydrogen, you often find the H plus ion. Here you'll find that there's a proton, but there's no electron in the outer shell. Hence, it's got a positive charge because the here you had a positive and a negative charge, so the overall charge was 0. Here you've got a positive charge, but you've got no negative charge to cancel the positive one. Hence, it's got a positive charge. Well, that's the 1.1 bit of the syllabus. We'll be doing isotopes next.